Hello, friends. So let's continue with the subject of power electronics of Gujarat Technological University. And in that, today we are going to discuss about buck boost converter. So in our previous videos, we have seen the buck converter, which is a step down converter, boost converter, which is a step up converter. Now this buck boost converter is a combination of buck and boost operation. So here, by selecting appropriate duty cycle ratio, you can use this circuit as a step down converter also and step up converter also, right? So the circuit is there in front of you on screen. Here you can see. So this is the switch. Here in this, I have selected IGBT as a switch. So through gate, I'm able to turn it on. The location of inductor is across the supply as shown. The diode is connected in a reverse fashion. And this is the resistance across which we are going to get the output, right? So the operation is discussed in the next slide. When the switch is turned on, you can see when the switch is turned on, the current flows in this fashion and the voltage which we get across inductor is equal to Vs. So in this situation, the diode gets reverse biased and the load is not that V0 part you are not able to see. So this is the voltage across inductor Vs when the switch is turned on for this duration, right? Now when the switch is turned off, so whatever is stored energy in this inductor is there, or whatever current which was flowing through inductor cannot vanish instantaneously. It continues to flow in this loop in this fashion, as you can see over here. And so the voltage across output you get in this fashion. So the thing is that here we get a output, but it is having opposite polarity, plus minus in a opposite fashion compared to what is available over here. So available polarity over here is plus minus in this fashion, but the output is inverted, right? So these are the two cases when the switch is turned on or when this is for the time t is equal to t off, which is nothing but 1 minus d times the ts, where d is duty cycle, which is nothing but t on divided by ts, and ts is the switching period of the power electronic switch, which we have chosen over here as a IGBT. Now these are the waveforms of buck converter. So you can see over here that when switch is on, the output is equal to Vs for d times Ts, which is nothing but T on period, and during which current increases from I1 to I2. This is the duration in which switch is turned off. So output is equal to minus V0, and it is for T off duration, which is nothing but minus 1 Ts into 1 minus D, that is T off period. So if I assume that a steady state is achieved, equilibrium is achieved in this situation, and volt second balance for one time period, that is this duration is one time period for which volt second balance is applied over here, then the area under this curve is equal to area under this curve. And if you apply this Vs into d times Ts is equal to minus V0 into 1 minus d times Ts. So in short, we get the output voltage V0 is d divided by 1 minus d times Vs with the negative sign. The negative sign indicates that this is an inverting type of converter where output will be having a say inverted polarity. Now here you can see if the D is between the 0 to 0.5 range, then you are going to get overall V0 less than Vs. So it will be working as a buck converter. And if D is in the range of 0.5 to 1, then it will be working as a boost converter, right? So by appropriate selection of D, the same circuit you can use as a buck converter also and boost converter also. So this was the quick review of the buck boost converter, and using IGBT, MOSFET or BJT, we can realize this buck boost converter. We are going to see the isolated converters in the subsequent section. So here we are completing the three varieties of the regulators, these DC regulators, that is buck converter, boost converter, and buck boost converter. We'll continue with the isolated type varieties in the subsequent videos.